My name is Idris Brewster. I'm Executive Director and co-founder of Kinfolk. I'll pass it to Angie.
Great. Hi, all. I'm Angie Fan. I'm head of product at Kinfolk, and I oversee product development and user experience at Kinfolk. I'll just pass it down the line.
Hi, I'm Prashas Thapan, head of engineering at Kinfolk. Responsible for all new features that are shipped and technical workflows, content pipelines, pretty much anything that's released on the app.
Hi, I'm Luna Wu. I'm the engineer at Kinfolk team.
Hi everyone, I'm Sahil. I'm an engineer at Kinfolk and Prior Interactive, helping with development and fixes.
Awesome. Thanks, you all. I'm excited to hear more from each of you as we go through the presentation. And I'm going to pass it over to Prashas, who's going to lead the slides.
Actually Idris is going to lead this bit, so I'll hand it off to him, and then I'll be back in a little bit to talk technical stuff.
Yeah, Prash is going to get to the good stuff. So I'll just start out by just giving an overview of what Kinfolk is. Kinfolk, we're an augmented reality archive for undertold histories, and we specifically focus on working with Black, Brown, Indigenous, Asian, and queer communities to find and preserve stories and histories that are not being told as much as they should in the larger spectrum of our history, and bringing those to life through the creation of digital monuments. And so our mission is to harness emerging technologies to empower stories of Black, Brown, and queer communities in public spaces through imagination and play. And our vision is an equitable future for all. Next slide. And so we started in 2017 when the New York City was thinking about what to do, reconsidering what to do with these monuments in our city. So there was a Christopher Columbus monument specific that Mayor de Blasio was wondering, do we take it down? Do we make it a landmark? Do we add context around it? And so my team, we created these digital monuments that told the true story of Christopher Columbus, as well as highlighted the stories of folks of figures that we wanted to highlight instead. And so what started as building out little prototypes in Unity launched into a large movement to be able to use AR to combat the representation issues within our country. And so if you look at this map right here, all these red dots, they are supposed to represent each a single monument in our country. And so there's 48,178 monuments in totality within our country. Next slide. And so out of those 48,170 monuments, only 240 represent Black and Brown people. And so when I saw this stat many years ago, it really was alarming, just because that's less than 1% of the monuments in this country. And another stat is that out of all the sites on the national sites for historical places in the country, only 8% are focused on Black, Brown, and people of color. And so we have to do something about this. But in order to build approximately 47,900 monuments, that is a tall order, especially when the price for one monument comes out to over $1 million. And so that's when, inspired by Pokemon Go, which is a game I loved and played starting in 2016, we were like, hey, if we can put Charizards and Bulbasaurs and Pikachus all around the place, we can use that same technology to put our stories in places where we want to see them exist. And also empower communities to do that on their own terms, without having to go through all these middlemen. Next slide. And so our solution was to tell as many stories and share these stories as widely as possible. So we believe that really by surfacing and sharing these histories, we can engage and empower our communities to reshape the world. And so our platform, which is now a digital archive, is designed to elevate these voices, narratives, and histories that have been traditionally ignored as part of the American fabric. And so the key part here is making sure that communities are telling their stories. In the traditional sense of an archive, what stories are deemed history is really determined by elite institutions and scholars. And so we want that same power to be given and acknowledged within our community members so that we can tell a diverse story about our history. Next slide. And so when we released Kinfolk in 2021, during the pandemic. And so what that meant was that we couldn't achieve our original vision of activating public spaces a la Pokemon Go. Some people call us Wokemon Go. But so what we decided to do was to release it so that you could engage with these monuments within your space. And so each of these monuments are hand created by our digital art team, led by Micah Milner. And actually, if anyone doesn't know Quill or Tilt Brush, it's the same technology where we're painting each brushstroke onto a model and doing spatial sculpting in VR. Next slide. And so over the years of doing this work, we started to become recognized as a leader in the field of historical preservation through emerging technology. And so just to cover some highlights in terms of our work, we were able to, in 2023, January through July, be a part of MoMA's exhibition called New York New Publics, which focused on 12 organizations that are going to change in the future landscape of public spaces. And so we got to demonstrate our technology to the widest audience yet. Thousands of people came to visit every day, got a lot of learnings from this in terms of how to engage with AR, specifically in the museum space. And here, these monuments grew out of these pedestals that we have. And for that exhibition, we focused on Seneca Village, which was a community in Central Park that was actually destroyed for the building of Central Park. David Ruggles, who was an abolitionist, and the Young Lords, which was a collective or group from the South Bronx that fought for liberation for Black and Latino folks. Next slide. We were able to be winners at the most recent Tribeca Film Festival, where we showed histories of New York, and we call this Black Land. So we showcased 3 different monuments built with communities across New York City. And we also displayed through AR videos that what it would activate when you pointed your iPad at them. Next slide. And so all of that was really great and helpful for our journey and learning how to build the product. But when we got to this point, to the middle of last year, we were able to connect with Niantic, who allowed us, as one of the teams that had previously built app on AR Foundation. They allowed us to be able to experiment to see how we could include Lightship within an existing AR Foundation architecture. And so we were able to release the location-based version of our AR in November. So we worked on it from June to November, around 6 months. And so in this, we added a map feature that would pop up, and then you could find little dots or landmarks on the map that you could engage with. You would also get notifications whenever you were nearby a monument. And then we'd be able to activate these. And so we then were able to, thanks to Niantic, be able to start our journey into reimagining our public spaces through the monuments that we had in the catalog. Next slide. And so we were able to launch our inaugural exhibition. Sorry. We were able to launch our inaugural exhibition, which was our signature monument series. We worked with 4 different artists from around the country, Hank Willis Thomas, Derek Adams, Tourmaline, and Pamela Council, to bring these art pieces created by more traditional artists rather than digital artists. And so our team really translated their visions into AR and went out and scanned each of the spots around New York City. So this was this monument by Hank Willis Thomas called All Power to All People. Next slide. That was actually able to be experienced at Brooklyn Bridge Park in downtown New York, or downtown Brooklyn. This was Mary Jones, which is the story of one of the first recorded folks who were considered themselves transgender in this country, which took place in New York in Soho. Next slide. This is the story of Fountain for Survivors, which was done by the artist Pamela Council. Next slide. And finally, we had the monument of Derek Adams, which you can go to Harlem to experience, and that really told the story of the founders of the Green Book. And so this was the start of the journey, and now moving forward, our goal is to be able to activate more spaces around the country with artwork, with monuments from artists, as well as from our community members and institutions that we're working with, like museums and historical sites and schools. So next slide. with that, I will pass it off to our head of engineering, Prash. You're muted.
Thank you, Liz. I am just going to dive into, with the help of Kinfolk engineers Luna and Sahil, how we actually integrated Lightship ARDK into the existing Kinfolk app, and specifically focusing on VPS and maps. So we had an existing product that we put geolocation on top of. So we didn't need geolocation to have our product, but geolocation was something that was always on the roadmap, and it truly enhanced this product. And we had attempted it before, like a few different times in different circumstances, and we weren't getting like the best results that we wanted to ship it on a public level. But that all changed with the Niantic technology that we're working with today. So just to talk a little bit about the architecture. Actually, before that, as you can see here in these slides, you can see the previous use case, which was placing monuments in a physical space, and then interacting with them to bring up all kinds of content like biographies, audio, video, and so on and so forth, that you can browse and learn about these figures from history. So to go into the architecture now, the first layer of our app is AR Foundation. That is where the augmented reality capabilities come from. And that is intertwined with our own asset management system, which helps us download assets from the cloud so that we can keep our high res, high quality assets out of the main app, so that we can keep the app size low for any user to download on the fly. This also includes data structures that we use to kind of combine various kinds of meshes, shaders, particle systems as we need to present to the user. So this was the core architecture before Niantic. And for geolocation, we used this baseline and added ARDK as well as maps. And the integration was very seamless. And we're going to talk about this throughout this talk. So I want to pass it off to Luna, who's going to speak about how we actually set up, went about adding Niantic Lightship and maps. So take it away, Luna.
Thank you, Prash, for showing us the classic use case of Kinfolk. And now I'm going to show the enhanced use case of Kinfolk after reintegrating Niantic technology into our pre-existing code base. So we use a geofencing technology and Niantic Maps SDK to show monuments at physical location from Niantic location database. Now, when user open the app, they will see the map, and on the map, there will be map markers with monument icon distributed throughout New York City. To generate these map markers, we pull data from Niantic database, and it's flexible enough for us to add our own design sensibility to it. Once the user enters the geofence, the user will get a notification to download the assets they need for the AR experience. After the download, the user will enter the AR space to start the experience. And now I will pass on to my colleague Sahil to go deeper into the geofencing logic and the addressable logic.
Thank you, Prash. Thank you, Luna, for the brief introduction to the architecture and our new use case. I'll be diving a little bit deep into the geofencing algorithm, what happens under the hood, how we were able to connect this with our existing asset management system, and the new features that we wanted from ARDK. The challenge for us was to integrate geofencing and with the Niantic locations to provide a streamlined geolocated experience. What really made it more convenient for us is how good ARDK synergized with the existing AR Foundation subsystems, which did not make us sacrifice our existing content placement architecture. We were able to sort of plug in these new features to our existing code base and make it all work together, and it was sort of like magic. ARDK also made it easy to get all of the Niantic location data from its database and connect it with our geofence data and the asset management system, which I will dive a little bit more deeper in the next few slides. Starting with geolocation. Traditionally, we have two popular algorithms in the computer graphics for detecting a point inside a polygon. Those two are the even-odd parity and the winding number method. For our use case, we went with the winding number algorithm. We derived the logic from that algorithm and sort of made it work with the latitude and longitudinal coordinates that will allow us to have this surgical geofencing around New York City, and then again have a nested geofence for each of the Niantic locations we wanted these experience to be tailored for. The winding number algorithm, as it says, it checks how many times a line segment has been wound around a point. Next slide, please. Yep, you can see in the picture, we sort of wanted to go for a very surgical geofence. But when we did the debugging and initial R&D on our end, we found out that for a very small geofence, we encountered edge cases for the algorithm where we would get these false positives or false negatives. And that messed up our entire UI UX flow. So to be on the safe side, we sort of went for a more secured quadrilateral geofencing, and the surface was a little bit larger. We went for 200 square meters square. That reduced these false positives to almost none. Next slide. Yep. As you can see, this is our data structure. We have the AR locations, the Niantic locations in the ARDK, and on the right, we have our geolocation data. You can see the geofencing coordinates that we have put into. These 4 points make a perimeter around the target location, and we were able to grab all of this data from the Niantic's database. Next slide, please. Yep. What really helped us was the geospatial browser provided by Niantic Lightship. This allows us to upload our scans, download these scanned meshes that we can then import into Unity. It also provides us with all of the data from its VPS coverage API, which is the Niantic location images, the address, the target location. Next slide. All right. Yeah, Kinfolk, before the geolocation release, Kinfolk had about 60 monuments, and the number keeps increasing with every release. So, to keep the app size as low as possible, and for our internal asset management, because we have huge number of assets, we have the AR meshes that we want for the monuments, we have these high quality textures, shaders, and the AR monuments in Kinfolk, they are interactable. So, when a user taps on it, it pulls up a bio card, and it has all of the content that the user can browse through. That includes like the narration audio, the biographies, the artifacts, and other extended learning materials. All of this content, including all the high quality textures, they're all bundled and stored on a server, which is downloadable in the app and updated remotely. For asset management, we use Unity's addressable system. This allows us to manage content downloads, caching on the devices, and also pushing remote content updates without even creating a new release for the apps. Once we had the geofencing algorithm working, the next challenge was the app should enable the new geolocation experience only if the users were accessing it in the New York City, because initially we released geolocation for 6 locations across New York. And to tackle this, we went for a nested geofencing system. We had a larger geofence that covered the entire New York City. And if the users accessed Kinfolk from within the city, the experience was available to them. Outside of the New York, the app would just work as it would before with the placement mode. Within this nested system, we have these smaller geofences for each of the Niantic locations. This is where if the user is nearby a location, the app would put a notification, in-app notification saying that, oh, there's a new AR experience available for you to experience, and you can go right about it. Next slide, please. So, sorry, next slide. Yep. So we combine these 3 systems such that the app would start tracking and localizing with the Niantic locations only if the user was inside the geofence, and when the bundle download was complete and the AR content was ready to be spawned. Next slide. This is how our new use case looks like, which Luna and Prash mentioned. Once the user enters the geofence, The app displays the notification banner, prompting that a new AR experience is available. It displays the Niantic location address, the AR monument that you would be able to experience there, the artists that we collaborated with, and also the distance of the same from the current user location. And all of this was updated in real time. Once the bundle download is triggered, the app prompts the user with a new UI to point the device at an Niantic location and start scanning for this. This is where the ARDK system communicates with our geofence system and starts the VPS tracking for it. Once the tracking is stabilized, it localizes with it and it spawns the AR content that we authored in using ARDK's editor tools. This is pretty much from my side. Thank you, everyone. I would like to pass it to Luna, who will speak about how we actually set up these AR experiences using Niantic locations.
Thank you, Sahil. Before I start with how Niantic technology helped us, I'm going to go back to early 2023 when we set up the exhibition at Museum of Modern Arts in New York. For the MoMA exhibition, we used the image scanning technology combined with geofencing to spawn Kinfolk monuments on top of 3 beautifully cut out wooden pedestals. The exhibition is set on the 3rd floor of MoMA. There is a huge glass wall that gives us a lot of natural sunlight throughout the day, but also casts a really hard shadow that moves throughout the day. Back then, we struggled a lot with the stability and the accuracy. We had to travel multiple times throughout the day to make sure the image scan worked stably with all kinds of lighting and weather conditions. And for one monument, Seneca Village, we wanted to sit right on top of the pedestal, and the bottom of the monument is supposed to line up exactly with the wooden cut off the pedestal. And back then, we need to make a lot of builds and do small positioning and scaling changing manually to adjust the position to make sure it gets the accuracy we want it to be. So if we have Niantic technology back then, the setup will be much more easy. Those 2 major points that we concern about, stability and accuracy, can be solved easily with the solution granted by us through Niantic location. Niantic location requires multiple scans throughout the day in different time periods to set up. This ensures that it will adapt to different lighting and weather conditions throughout the day, which solved the stability problem we had at MoMA. And here on the slide, you can see Prush scanning the location at different times in a day. And here is an example of how stable it is to spawn monument at the exact location in different weather system. Niantic location also help us to convenient set up in editor. And here in this slide, you can see an example of a scan mesh of the Union Square. You can see that because of the detailed mesh, it will be really easy for us to line up monuments exactly where we want, and that will help us a lot with the accuracy when we set up Seneca Village and MoMA. So a major challenge we are facing when we're testing geo-based functionality is the need to travel to various locations. This can be really time-consuming and also logistically challenging. However, the use of private location offers us a solution. Here you can see we set up a private location by scanning our studio flag, which is right behind me. And to set up this private location, it only takes us 1 scan, and it's quick and easy to set up. It's helped us a lot in the early R&D phase of the developments. It's such an efficient tool, especially when us as developer want to demonstrate how things actually look in the AR space and communicate internally with artists on our team. To further enhance our testing, we also submit a couple of locations near our studio as public location. This not only allows us to test it in the real world environments, but also encourage us to get out of our chair and just move around in the daylight. As you can see, once a Niantic location is set up, it's really easy to load in Unity and switch between them in editor to tweak and test. I also want to touch on the point about how easy it is for us to integrating our pre-existing database with Niantic data structure. Here you can see in the new data structure that we create, we combine the Niantic database we pull from Niantic database and with our monument data and addressable data structure that allow us to create this new data structure seamlessly and give us freedom to bring Kinfolk monuments with the power of Niantic geolocation technology in AR space.
Thanks so much, Luna and Sahil. So at this point, we have a functioning app which runs geolocation, but now it's time to actually put these monuments in the space designated by the artist that we're partnering with. So that brought challenges of its own. To start with, as you can see, this monument of Mary Jones, directed by the artist Tourmaline, it's a very giant monument, and the scale is like maybe 4 or 5 stories tall. And in our previous use case, our classic use case, I should say, where we could place monuments in physical locations, just in your living room or in your yard, we have a benchmarked default scale for monuments that we want to have for that. So we can't just, have a 30-foot monument in that system. So we had to figure out how to get around that. And maybe this is something that it's a handy trick that could help you as developers if you have a similar situation with existing content and need to reconcile it. So how we did it was like this. On the left is our Niantic location in Soho, and on the right is an empty game object. This is all we shipped with the app. Now, the empty game object does 2 things. First of all, it lets us change the position, rotation, and scale of our monument based on the Niantic location. So that is great. The second thing is it cuts down on our app size because we're not shipping any heavy content with the Niantic location. We're simply shipping an empty game object. So it eliminates any app size concerns. So it's a handy little trick to use. So if you see the final product, we have Mary Jones, who is at the right size, but we didn't have to change her size for our default use case. Just to give you a comparison, on the right is Mary Jones at the size she is in Soho, whereas on the left is our life-size scale, which is about 6 to 7 feet tall, the benchmark scale we have for the Kinfolk app. So, we hope this could be a handy little trick for you to use as well when you're using Niantic locations, either in private locations or public locations, to be able to manipulate content you might already have in your app and change it to be however you would like. Another challenge we had was when working with Hank Willis Thomas's iconic sculpture, and we were directed to put it in the middle of the East River. And while Niantic locations can give you that centimeter accuracy, there's semantic segmentation and things like that, but there's like no real way right now to like position something precisely that far away. So we had to figure that out. And yeah, Sahil is going to tell you all about it.
Thank you, Prash. All right, Afropic at Brooklyn Bridge. That was the trickiest location we had to spawn our content. Initially, we had 6 locations where we deployed geolocation experience for, with this one being the most tricky part. Next slide, please. So initially, we went for a very weird way of trying to gauge the position of the monument. We went to Google Maps. We used their handy little measure distance tool to calculate, okay, how far this is going to be from the Brooklyn Bridge and from the pier. Because the Niantic location where the devices would localize with, or where the VPS tracking would be enabled, was around 800 to 1,000 feet away from the actual placement location. And the placement was to be precisely above the surface of the water and a certain distance from the Niantic location. Next slide. Yeah, on the left, you can see that was our first placement with just the editor tools that ARDK provides. We sort of gauged uh, a ballpark. Okay, this is how far the monument could be from the mesh for it to be spawned properly. But when we went on site, it was all haywire. The orientation was wrong, the scale was wrong, the offset was not very precise. So we sort of had to write our internal debug tools for this. One of which is the offset calibration tool. What this tool does is, it was basically, you author the AR content in the editor using the AR content root system that Prash talked about, which would take care of spawning the monument. But to reduce the iterations of doing that in the editor, I'm making constant dev builds and having someone from the Pariah's on-site team go to this location to test for the accuracy. This tool sort of like just reduced all of that iterations, and this enabled us to get the accurate position and orientation with minimized time and efforts. What this tool did was, once the VPS system was localized with the Niantic location and the content was spawned, it would allow us to change and record these transform values of the AR content root at runtime in the app. So you could change the offset on all three axes. You could change the orientation and also scale of the root content. And these debug tools, you can see there's one more in the background, a small icon where you could see the debug logs from our code. All of these tools, they were sort of put into the release build as well, and they were accessible with a certain secret gestures that you would do in the app, and it would open up these tools for you to debug. By the way, these are still present in our public release with the secret gestures, and they still help us debug issues every now and then. But yeah, this was like one of the challenge, but there's always more with the development, and I think Luna will take it forward for the rest of it.
Thank you, Sahil. So after solving the problem with the long distance, we are now facing another problem: how to guide user to look at these monuments on the water. To address this, we implement a feature internally called Grace Trail, which we pull inspiration from this video game. You might have heard of it. So Grace Trail is the particle effects that travel from user's camera forwards to the monuments until the user turn around and look at the monuments. It will guide the user to walk around obstacle or turn around to face the AR experience. This design solution effectively solved the technical problem of guiding user to the exact waypoint that we want them to be after the monument is spun. This is also a very good demonstration of how flexible Niantic tech is for us to build a better and customized user experience on top of it. So since we shipped this version of app last November, we have a long way to go, and we are always learning from our users.
Oh, oops. Thanks, Luna. So today we've covered how we added ARDK and maps to an existing core architecture built on AR Foundation, and how seamless that was. We were able to not only add these functionalities, but extend them and also integrate them with things like our own geofencing algorithm. And the code bases were clean enough to combine really, really nicely. So to conclude, I would like to invite Kinfolk's head of product, Angie Fan, to sum it all up.
Thanks so much, guys. So to wrap things up, I'd like to offer one more perspective on product development for you all to consider. Next slide, please. So I'll start with before Niantic. Due to our roots in technology and activism, we knew from the beginning that our approach to empowering our communities would utilize AR technology and be site-specific and place-based. So to that end, early Kinfolk offered two modes. One was place mode, which allowed users to select a monument and then place it almost anywhere. And then also a scan mode, which was an image market solution that allows users to scan an image to then pull up AR content. And yeah, you can go ahead and play that video. So as we look over these images, I ask you to consider the difference in the app experience between this slide and the next. While these modes did solve for our base user needs and scenarios, they did have their own limitations. So as you can see in the place mode, the user still has to choose what content they want to activate, and then they have to make more choices around where am I going to put it? How do I interact with it? On the right side, you see some printed materials required for our scan mode. And in order to activate scan mode, especially at live events or activations, we had to have printed materials installed on site with instructions in order for people to be able to access the app. Next slide, please. One thing we do when we're developing our app is we talk to our users and communities and partners to get their feedback on what they'd like to see. So one request we got over and over again was the ability to tell site-specific and geolocated stories. With that in mind, when we got the opportunity to work with Niantic and use VPS technology, we were ready to go, fully on board. So the introduction of VPS technology allows us to incorporate wayfinding, location activation, and place-based content all within the app. Maps and VPS also allows us to place artworks and archival media in context of the people, the communities, and the history that they are important to. So it also offers a level of accessibility and granularity that wasn't available in our app before. So in that way, Niantic has really allowed us to expand our product development horizons in terms of meeting the needs of our communities. And we now have 7+ partnerships nationwide lined up for 2024. And we're releasing with maps and VPS technology in use. Thank you all so much.
Thank you.
Roots of
Great work. All right, so is that the end of the presentation for you all? Yes, awesome, cool. Thank you all so much for sharing all of those great insights. We have one question coming in through the Q&A, but if anyone else has any questions, please at this point feel free to use the raise hand feature or just drop it in the chat and we'll get to you all as we go through this. So the first question is coming from anonymous participant. Does the main future monetization of this AR app primarily come from national partnerships?
Yes. So we are a technology nonprofit. And so because of our mission and our focus, we are mostly raising money through foundations and individual support. And that will always be a part of our business model, but we're looking to supplement that model with more earned revenue through national partnerships. And looking future 3 years down the line to how can we also incorporate education into that earned revenue model. But there is a lot of interest from cultural sites across the country and the globe in terms of how can we add another layer onto our site for storytelling that doesn't require us to make physical changes to these sites. And so it's a lower cost way for them to add new voices onto their sites and add a different experiential activations. So that is a part of the business model moving forward, but we also are just melding that in with our foundation grants.
Oh, thank you for answering that. We have another question in the chat. I'll get to that one in just a second. But I kind of have a follow-up to that, Idris. You mentioned global locations as well. How is that planning going along, and how far out are you all from taking this beyond the United States?
Oh, well, I mean, we're still focused on the US right now, but we were in a museum exhibit in Brazil in September of last year, where they brought the Black Lands exhibit I spoke about in Tribeca over there. And I mean, the representation issue, while the stats I mentioned here were focused on monuments in the US, I've talked to people around the globe that share the same concerns around their cities and their stories. And so we are trying to create this in a way that can expand globally. And if the right global partnership comes up, like we will do it. I know London also has a lot of AR activations that are pretty heavy over there. And so there's definitely interest. But as of right now, at least over the next year, that is not a real focus of ours. But of course, a partnership may come along, so we're always open to it.
Awesome. Yeah, I think Mike is kind of trending in the direction where my question was leaning in, asking how much can the user community help with the placement of content and at the geolocations?
That's something that we're exploring. I think up until this point, we've activated at community events with using not using geolocation yet, but we've activated our stuff at community events. And so while right now we take suggestions on monuments that we want to place, or what monuments to create, there is a future that I hope to see in which people, which I know Niantic also might be able to help out with in terms of users selecting spots, but also scanning spots on themselves, by themselves in app. And so that's definitely a consideration for us moving forward. And an ideal place for us to be is how can we lessen the time or the space between users and then activating these monuments in certain locations. We want to try to
Gotcha.
give as much agency as possible.
Awesome. I'm just gonna go ahead and ask Gerard's question for him. Do you have any mentorship or internship programs?
Well, not at this moment in time. I think internships is something that we are considering and thinking about. And so we would love to, if you can reach out to me, or anyone on our team, it's our first names at kinfolktech.org. We would love to explore if there's certain opportunities that present themselves. We don't have an official program yet, but we're open to people reaching out and finding a way that we can integrate you within our work stream, because we work in a lot of different areas.
Awesome. And then one question for the more technical side of things. When you all are scanning, you provided that really great example video of you all scanning. But one question that we get a lot from developers that are building VPS experiences is how do you incorporate scanning an object that is big, right? So something that is already big in of itself. How do you focus on a specific landmark within that, or what do you recommend doing in those cases?
Yeah, I can talk about that a little bit. So the best results we get, no matter if the object is big or small, is to kind of pull back and then pull forward. So if your object is big, you're going to be quite far behind. So you're going to see it from a distance and capture it within your phone screen. But then you also want to make sure to come forward and look at it up close, because that really seems to help us. And while you're doing this, make sure you're going around in a circle as well. So what ends up happening is this kind of flower shape from a bird's eye perspective. No matter if the object is big or small, that's the pattern that we found works really well. Also, we've talked to developers at Niantic about that, and that seems like the way to do it. So that's what I would advise. And for a really, really large space, we've had pretty good results with like scanning different parts of it, because I know you can scan for up to 5 minutes. So maybe that's not enough for you, but just keep scanning in different times of day and keep building that, localizability over time.
Awesome. Thank you. And Andy, so you have your hand raised?
Yeah, hi. First of all, thank you so much for this presentation. I'm on Unity's Air Foundation team, so appreciate the nice things you said about us as well. But want to talk a bit about your process, taking the Soho installation as an example. Basically, how do you sort of get from the concept of, hey, we want to put this at this specific location, to like, at what point do you actually go to Soho? And did you build any of your own editor tooling, or just use what's available in ARDK to sort of get a sense of scale and setting up the experience before you went down to Soho? Or how often did you go to the physical site as you were working on this?
Yeah, that's a great question. So at first, we do have to go to the site to scan it and make it a Niantic location that's available through geospatial browser. So that's the very first trip we will take. Then once we have the mesh that we can pull into Unity Editor, we had to integrate it more with our existing tools that we use, addressables, like I said, to download content and serve it up. So how we're instantiating in the classic use case of place mode and scan mode, we also have to adapt that to instantiate into, geolocation. So we can do a lot in the editor. We can check how it looks and stuff like that. But the thing is, even the Niantic mesh, it's not going to have the whole street. It's not going to have, cover everything. We would need to scan a whole lot to get all of that mesh. So that's stuff we can't do. So once we have like a ballpark idea of where the mesh needs to be, and the size needs to be based on mockups provided by Idris and the art team on Kinfolk, we look at those, we study those, and then we try to do it as well as we can in the editor. Then actually we still don't go to Soho. We will do it at a public waste spot near us. So we'll see if the scale looks good, if the position looks good, and so on. If the scale looks right, if it feels like, okay, it's 4-5 stories tall, it looks kind of like the mockup, now is the time we go to Soho. We will use that calibration tool that Sahil spoke about to adjust if we need to, because we can't see the road, as I said, in Unity. So we'll adjust it on site. And that's really when we get the value of going on site to like adjust it and see how it looks. Then we provide a few screenshots or videos to the artist, in this case, Tourmaline, who will then look it over, and we'll just keep iterating until we're ready for launch.
Well, there were actually a good amount of trips that we made after this process to now just check if this was correct. And then there was a part of it, it's whereas like we didn't really know how the location was going to feel until the positioning was going to feel until we actually went there. And so when we traveled there, we're like, oh, this actually looks better further down the street. And we brought the artist Tourmaline as well to look at it on site and get approval. And it did become trickier when the location was further away from the scan point. But so there was a good amount of trips just to double check the location, and we had to use the debug tool ourselves and send them the coordinates from the debug tool, so they could input that directly into the system. So there were a good amount of trips.
Yeah, but with the editor tools, we were able to eliminate a lot of those in the pre-production process, and it did become more about like, okay, now once it's on site, how does it look, how does it feel? But that initial functionality of is it going to spawn at a Niantic location? Is it going to spawn at the right scale at a Niantic location? Those kind of tests we're able to run before even going to on-site. Yeah.
Awesome. Thanks so much.
Great question, Andy. Thank you. We have time for one more question. If anyone has one, feel free to unmute, or if you're typing in the chat, type quickly. And otherwise, we'll go ahead and wrap up here shortly as we're about to hit 12 p.m. Going once, going twice.
I can jump in here.
Yeah.
Hey, it's Todd Little here. To kind of bounce off Andy's idea, have you guys looked into things like Gaussian splats as reference material, as giving you context, sort of 3D context of what the space is going to be like before you even go down there, like taking video and then converting it into a 3D render?
No, we haven't done that actually. When we were getting the meshes from the geospatial browser, it would provide us enough data that we could estimate things, but you're right, like that with that we could possibly even get extended data of the surroundings beyond what the Wayfarer scanning app could give us. But not yet.
Not yet.
Long story short, yeah.
Cool. Well, great talk. That was awesome.